All right, welcome back. Ester reactions. So, we see this part right here, and so we have to remember that we have our ester functional group. So, something's going to happen where at the end of the reaction, we'll be left with this. All right, and so we know that over here is the so-called rest of the molecule, the R group, and over here is an R group. And so, something has to happen with a reaction where essentially we can find this part, this functional group that'll link together this side of a molecule, however much it is, and this side of a molecule, however many atoms that is. But when we find this, we know we have an ester, and that's kind of the focus of some lab work that we do. Okay. um, well, let's just jump into it. Let's see. I'll leave this. I'll move this over here just so we can have that there. All right. So remember, we're looking for this as we're looking at our mechanisms. Okay. So again, now let's figure out what this word mechanism means. So you've heard of mechanic or a machine, machines, things like that. So a mechanism, if you think of a machine, like a mechanic, you look at all the different working parts, the different pieces that come together that all have an overall function. So in chemistry, when we talk about a mechanism, what we do is we talk about kind of like a couple of different reactions, a series of reactions, or we're looking at part of a reaction that's happening. And so when we look at our ester reactions, we're going to be looking at one particular kind of feature that is happening, and we're just calling it a mechanism. All right. Some of these mechanisms get really, really complicated, but we're not going that far. Don't worry about it. All right, so let's get started. To form an ester, we essentially are going to, there's going to be an alcohol, plus there's going to have to be some sort of organic acid. Okay, and then that is going to make our ester molecule. Okay, and so for an organic acid, we know organic acid, we obviously are going to have something that has the carboxylic acid functional group. And what else is attached to it? We have no idea, so let's just look at this R. For something to be an alcohol, we know that it has a hydroxyl group on it. And what else is with the molecule? What? We have no idea. It's just some other R group. It could be a small one, could be a really large one, doesn't matter. The focus is always with this and this functional group. And so you should already be able to see that for our ester, here's a carbon double bond to oxygen, there's carbon double bonded to oxygen, and then something else is going to be happening to remove the rest of this so that all we have is this part right here. This should bring you back to some previous lessons we've had on condensation and hydrolysis. Remember condensation, dehydration, synthesis, and so that's a type of mechanism that brings any two of these organic parts together. And so we're going to obviously, these are going to go through a process of condensation. And remember, with condensation, what comes out of the process is always water, right? So if we think about that, that means we also have water as a byproduct here. And so this entire thing here, this whole thing here sums up the concept of an ester reaction, esterification. Now there are a bunch of different types of ester reactions. this is the type that we're going to be focusing on. This is the focus of our studies in class and our lab work. So let's do an example of this. All right, I'm going to leave this right here for us to look at. And let's take a very basic alcohol. So the most basic alcohol obviously would be something that has one carbon. So we need the hydroxyl group. And then we've got our hydrogens. Okay. And then let's think about this. If this were just this one carbon right here, this would be methane. So obviously from our studies in class, we know this is methanol. Okay. So now we have to add it to an acid. Let's go with something like, oh, I don't know. How about let's use propane. So if we had 1, 2, 3, and then we had an acid there. I'm just filling in my hydrogens. Okay. And from a previous lesson, we know that this right here would be propanoic acid. Okay. So there's our alcohol. And here's our acid. Let me move that plus sign out of the way, kind of center it just a little bit better. Okay, we're going to have our reaction arrow. And we should note that these reactions need a catalyst, and very often that catalyst is going to be a concentrated acid. So that's just the abbreviation for concentrated, C-O-N-C period. It's concentrated acid. And typically, like in class, the concentrated acid that we're going to use will be sulfuric acid. Okay? So since I know that, what I'm going to do is I'm going to come over here and I'm just going to write sulfuric acid. Okay. If you just think about the concept of acids, you have all these extra hydrogen ions that are there. Those extra hydrogen ions kind of help bring in some energy that helps push these things together, which will help kind of get the reaction going. All right, so you see this right here. Now you see how I have this written to make it easier for us to understand what's going on. Let's flip the molecule over. Okay. Let's flip the molecule over. All I'm doing is taking and flipping it 180 degrees, which is what happens in real life anyway. These things are always flipping and rolling and moving all over the place. So now you should see this looks very much this looks very much like something that we talked about before with the condensation reaction. And right there's your H2O, and water right there is going to come out of the reaction. All right, water is going to come out of the reaction. So now, if you think about it, let's try to visualize this. You should be able to see that this oxygen right here has to come over here and bond with that carbon right there. All right. That oxygen has to bind with that carbon right there. All right, so worry about putting all of this together. So right here, this oxygen has to bind with this carbon right here. And you should be able to see that what's highlighted here matches that right there. So let's just go ahead and redraw this. So draw the center part, draw the ester link first, then worry about the rest of the molecule. That's what I think is easiest. So we've got the oxygen. So we see we have an oxygen that is bonded to the carbon, which is double bonded to an oxygen, and then that bond comes out. oxygen, oxygen, oxygen bonded to a carbon, so there's the bond right there. Carbon double bond to oxygen, carbon, and then that bond right there. And remember, I'm drawing this straight up from a previous lesson we've talked about. When these two molecules come close together, the electrons that are here and here, they're going to repel. So it's going to force this atom to sort of bend back up more this straight upwards angle from this carbon right here, okay? So now all we have to do is draw the rest of the molecule. Well, right here, this oxygen is bonded to that carbon, so let's go ahead and put that on there. Then we have 3 hydrogens on there, so let's just add those 3 hydrogens. This carbon is then bonded to 2 carbons. And you can see there's 2 hydrogens, and then the end, methyl group is pretty much always at the end of what we've got. And you should be able to see we have our ester group just like here. So right now, this is our R group right here, and this is the R group right there. So it works out. And then I'm notorious for this. The water came out, so we can't forget to write plus H2O. Now we have a balanced reaction that shows that's following the law of conservation of mass. All right, so now we just got to figure out how to name this thing. Okay, so when you name, so here's our ester. This is our ester compound right here. So let's figure out the name for this. So if we think about it, this is the ester, and linked to this ester right here is something that looks like methane, but it's an alkyl group, which we know is methyl. And so we remember this from previous lessons. 1 carbon extension right here we would call methyl. The base part of this molecule is propane. But we can't say methylpropane because there's an ester here. So here's the way this works. You look at you take the ending, and you add O8. So for an ester compound, you have to drop the ending and add O8. So we would call this methylpropanoate. Methylpropanoate. That's how you would pronounce that. And then plus water. And you're going to find this. This usually has like a, it's got like a fruity sort of rum-like smell. Okay, I'm just adding that in. So these organic acids and alcohols, when they mix together, they produce these different fragrances. And usually most of them are fruity in nature. We're going to look at some more examples of that. All right, so let's do that. Let's look at one more. Let's look at one more. How about something like, I don't know. Let's get how about this? Let's go with a larger alcohol. 2, 3, 4, 5, 6. Larger alcohol. 6 we know would be hexanol, right? So this is hexanol. Or we know this is hexane 1-ol, right? If we follow the other naming system. So put all of our hydrogens in. I don't always put the hydrogens in when we're doing training stuff, but yeah, I know right now this could be helpful. So There's all the hydrogens. So we've got an alcohol. We need an acid. Let's see. Let's go with 4. 1, 2, 3, 4. And I'm going to go ahead and put the carboxylic acid functional group on this side, since we know we have to get those two to react. Now just fill in your hydrogens. All right, and you should be able to see right there, that's where the water is going to come out. So here's hexanol, and then 1, 2, 3, 4, that's butane, right? Oops. Let's see, let me go back to blue, and that side, there we go. So this is butane, right? So remember from previous lessons we've had, so we take butane, and remember we drop the ending. You drop the ending, and then you add oic acid. So let's take hexanol and butanoic acid. Let's see, I'll make this a little smaller for you. That didn't work. Let me grab all of that for you. There we go. Draw the arrow. And we know that we need a catalyst, and the lab work that we're going to do, sulfuric acid is what we're going to use as a catalyst. Ester, remember, remove all this. You should be able to see that all that right there, all that goes away. And now this oxygen combined with that carbon right there, and all of a sudden we get our ester. So let's start with the ester. We know that we're going to start with C. Let me move over. Oops. Let me move over a little bit. We know we start with that carbon, double bonded to an oxygen, single bonded to that oxygen. That's where it gets linked. Now we just need the rest of the molecule, Okay? So over here, let's go on this side. We had 1, 2, 3, 4, 5, 6. It's going to get a little cramped, but I'll get this. I'll figure it out. 1, 2, 3, 4. Oops, this is really bad. All right, let me see if I can do a better job for you here. So 1, 2, 3, 4, 5, and 6. And so we know we've got hydrogens. And then we've here this carbon here. And then we need to add 3 more hydrogens on this side. So that's 1, 2, 3. Just add in, carbon, sorry. And just add in your hydrogens. You should be able to see that it's basically the same pattern over and over again. We're just taking the alcohol part, the hydroxyl, the carboxylic acid part, combining them, removing water, which means there also has to be plus H2O. We're combining them, and then we just put what the R group is. We just put the rest of it. So, right here, there's our ester group. And the extension on the ester right here is a 6 carbon chain. 1, 2, 3, 4, 5. So we know that's hexyl. All right, and then 4. 1, 2, 3, 4. 4 is butane. remember from what we've talked about before, you drop that ending, and then remember we dropped the ending and then we added the O8. So it's going to be methyl or hexyl butanoate. That would be the name of this ester, hexyl butanoate. So there's a couple of examples. So let's recap everything. Remember, you have an alcohol and an organic acid. It's going to make an ester molecule, and then you're going to get water as a byproduct. We're only focusing on the functional groups. Whatever the rest of the molecule is what it is. It is what it is. So look at the basic mechanism. Remember, it's condensation. Water's coming out of it, and our carbon was a single carbon group here, methanol, for the alcohol, propanoic acid, and then we just linked it together. Notice we got water coming out, and you can look this up. I just happened to remember this one. But methylpropanoate kind of has like a very fruity, almost rum-like smell. So like sometimes when fruits, sometimes you'll get like a fermented smell. That's what would happen right here. Hexyl butanoate. This right here is a common scent that that gives some apples, the smells that they have. So when you go, oh wow, that smells like apple, you're probably smelling hexyl butanoate molecules that are kind of free floating in the air. All right. All right, there is our basic lesson on ester mechanisms. I'll do some others as well, and just be on the lookout for those. Hope this helped. Take care.